Hello, I'm going to talk about 2.5 in our textbook. It's solving equations with variables on both sides. This you should already have in your notes. These are the steps for solving equations. So you have to remember your goal. Your goal is you want to get the variable by itself on one side of the equal sign. So the first step is always to simplify both sides of the equation, and you actually have to simplify between every single step. The second one, which we're going to focus on today in this lesson, is to get the variable to one side of the equation. Before, we were always skipping that step because it was always on one side of the equation. Now I'm going to give you a couple of equations where the variable is on both sides. And then once you have it on both sides, simplify the equation, and then it becomes a two-step equation, and you just have to do backwards PEMDAS. All right? There's a quick tip that I want to give you guys. For step 2, when you want to get rid of the variable and get it to one side of the equation, always just get rid of the smaller variable. And I'll show you what that means with this following example. Alright, so we have 7 minus 8x equals 4x minus 12, or 17, sorry. First thing you want to do, thinking bubble. What's smaller? Negative 8 or 4? Because the coefficient of this x on the left-hand side is negative 8, and the coefficient on this x on the right-hand side is 4. So which one's smaller? Negative 8 is definitely smaller than 4. So, according to my tip, I want to get rid of the smaller x. So let's get rid of this negative 8x. The opposite of negative 8x is positive 8x, so plus 8x to both sides, plus 8x. We're left with negative 8x plus 8x cancel out, and we're left with 7 on this side, equals 8 plus 4 is 12, so we're left with 12x minus 17 because we did nothing with that. All right. Now, like I said, it becomes a two-step equation. Do what we need. We have to do backwards PEMDAS, so plus 17 to both sides. Whoops. These cancel out. We're left with 12x, 14, carry the 1, 24, and then to get rid of that 12x, or that 12 rather, divide by 12. These cancel out. We're left with x by itself on this side and 2 on this side. See? So the only new thing that we have to do in these types of equations, when we have the variable on both sides of the equal sign, we have to get rid of the variable from one side of the equation. Now, suppose you just didn't know about that tip that I gave you right over here, where we want to get rid of the smaller x. If you didn't know that, and you just got rid of the other x instead, you would still get the same answer, and I'll show you. Now, let's get rid of this 4x over here. The opposite of positive 4x is negative 4x, so negative 4x to both sides. And 4x minus 4x cancel out. We're left with negative 17 on this side, and that's going to be a negative 12x, and then a positive 7 on this side. We want to get x by itself, so subtract 7 to both sides. These cancel out. We're left with negative 12x, that's a 12, equals negative 24. Now we have to divide both sides by negative 12 to get rid of both the negative and the 12. And you're still, again, left with positive 2. The reason why I gave you that tip in the previous slide to get rid of the smaller variable is because when you don't get rid of the smaller variable, at the end you're left with a negative variable. And you just have to deal with that negative at the end. Like I said, if you don't do it in the beginning, it's completely fine. You'll still end up with the same answer. It's just a tip. Okay, let's go on to the next example. Next one. This one we have to simplify first and then get all the variables to one side. So with this one, let's distribute that 1/4. Distribute it to the 16 and distribute it to the 60. So I'm just going to rewrite everything on the left-hand side, 9x, because I'm not doing anything with these. I can't combine them. I can't simplify them. Multiplying by a fraction is same thing, dividing by the denominator. So 4 1/4 is 16. It's the same thing as saying 16 divided by 4. 16 divided by 4 is 4. 1/4 is 60. So 60 divided by 4 is 1/15. Right? Now we're left with variables on both sides of the equation. Think to yourself, which one is smaller? So look at the coefficients on both sides. We have a 4x over here and a 9x over here. 9 is bigger than 4, so therefore 4 is a smaller variable, so I want to get rid of that one. So subtract that 4 to both sides. These cancel out and you're left with 15 on this side. The minus 5 is still there. 9 minus 4 is 5x. Right? And then it's a two-step equation. Plus 5 to both sides. 5x equals 20. Divide by 5 to both sides. And you're left with x equals 4. Yay! Cool. Now, we're going to get to some special cases. The last two examples that I have here are the special cases. So let's solve this the same way we've been doing. Simplify both sides of the equation first. So here I have to distribute. So distribute this 3x to the x and to the 4. So we're left with 3x equals 3x plus 4. Now we have variables on both sides of the equation. Both of them are equal, so let's just get rid of them, right? I want to get rid of x from one side of the equation, so let's just get rid of this 3x by subtracting 3x to both sides. 3x minus 3x is 0 equals 3x minus 3x is also 0 plus 4. What happens here? Simplifying this the right-hand side, you're left with 0 equals 4. That's not a true statement. That's incorrect. 0 does not equal 4. Therefore, the answer to this problem is no solutions. What that means is there is no value for x where this top equation will be correct, will be true. So you can put in any number that you want for x, and that equation will never be true. That's what it means. Let's go to the next example, which I'm pretty sure you've seen before. Let's solve this. So first thing you have to do is simplify both sides. Distribute this 2 to both the x and the 5, so rewrite everything else. 2x plus 10 equals 2 times x is 2x. 2 times 5 is 10. Look at here. We're left with a correct statement. 2x plus 10 equals 2x plus 10. That's true. That's the same exact thing on the other side. That actually has a special name. But first, let me just tell you what the solution is. The solution is all solutions. Any number that you put in there. So x is all real numbers. Any number that you put in there will be a solution. Doesn't matter what you put in there, it will always give you a correct answer. This special equation is actually called an identity. And an identity just is an equation that is true for all values of the variable. Quick side note, I'm sorry, I didn't even mention this before, but that little symbol there, that just means in the set of. Remember when we were talking about sets? This is a set of all real numbers, which contains all rational and irrational numbers. And this little math sentence that I made here just says that x is in that set of all real numbers. So x is contained inside that set. I went a little bit collegey right there for a second. All right. So that's it. That's the only new things that I wanted to show you. I will be putting the Alex topics on the comment section that you can master now, that you've seen this lesson. I would master it now, just so you don't have to do it later on. All right? I'll see you tomorrow. Bye.